Hello everyone, welcome to Dakshana e-classroom program. In today's lecture, I am going to discuss the solution to paper DT08 part physics. I hope everyone tried their best and hope like all your doubts and questions which you were not able to solve in your exam, you should be learning the things, learning the approach, how to solve those type of questions after going through this video. So let's continue with the question number 1 and here we have a particle of mass m is suspended from the ceiling through a string of length L. Particle move in a horizontal circle of radius R. The speed of the particle is. So the question is question number 1. Here there is one particle which is like rotating like this and its radius is R and this is length is given as L. So we can write this will be equal to I can write under root L square minus R square. And it's rotating, so let's say T is the tension, particle mass will be mg, and then if I take this as theta, then this will be also theta, so it will have T cos theta this direction, T sin theta and T cos theta, right? And just balancing the forces, then I will get T cos theta equal to mg and T sin theta will be providing the required centripetal force mv square by r. And this is, let's say, equation 1, this is equation 2, then 2 by 1 I will get tan theta, that is equal to v square by rg. And tan theta from here can be also written as, that is r divided by under root L square minus r square, and v square is equal to r square g divided by L square minus r square, and taking root of this, then I will get v is coming out to be r under root g, and this is L square minus r square power 1 by 4. That is the answer to the problem, and which matches with option 2. So this is question number 1. Next, question number 2. 3 point masses of each m are joined together using a string to form an equilateral triangle of side A. So 3 particles are joined like this. Particles A like 1, 2, 3, and this side is given as A, forming equilateral triangle. So each side is equal to A. Okay. Equilateral triangle. The system is placed on a smooth horizontal surface and rotated with constant angular velocity omega about a vertical axis passing through its centroid. The tension in the string. So now this system is rotated about this centroid axis, right? So this total angle will be 60 degree. This will be, I can write 30 degree. So now what will be happening? Tension in this T, tension in this is also T. Then T component along this must be providing, that is 2t cos of 30 degree must be providing m. This, if I take this distance as r, then it's r omega square. Clear? And now it's asking about the tension in each of these strings. So I can write this is 2t into cos 30 root 3 by 2 equal to m r omega square. This implies T is coming out to be mr omega squared divided by root 3, is it? But here, because I am not provided with r, so I need to substitute r. So then this r, like this is the triangle, and this I know is actually equal to how much? A by 2. This angle is 30 degree, so r will be, I can write r cos 30 degree is equal to a by 2, and this implies r is equal to a by root 3. Substituting it here, then I'm getting tension is equal to ma omega square by 3. This is the answer to problem number 2, that matches with option 3. Okay, next question number 3. A cradle is h meter above the ground at the lowest position and capital H meter above when it is at highest position, point V. If V is the maximum speed of the swing of total mass m and relation between swing, then total mass m and relation between h, small h and capital H. So this is sort of like a vertical circular motion situation. Here this is the reference, so I'm taking this is the height small h, and here definitely the speed will be maximum, that is given as v. And when it is reaching to the maximum height, then it's given as this is having total height what, that is capital H, right? Then I can take almost the velocity here, critical minimum condition, final velocity will be 0. That's simple. Now application of conservation of energy. So what I will write here, total energy. So let's say this is point A, this is point B, so I can write mechanical energy at A must be equal to mechanical energy at B, right? This is the problem. Then mechanical energy, here I can write mg small h plus half m v square. At highest point it will be completely this, and m gets cancelled out, and dividing by like g, then I'm getting v square by 2g plus small h is equal to capital H, and this matches with option number 2 for problem number 3. Next question number 4. A stone of mass 0.5 kg is attached to the string of length 2 meter and is wheeled in a horizontal circle. Okay. If the string can withstand a tension of 9 meter, the maximum velocity which the stone can be wheeled. Okay, so here what's saying, like this is in horizontal plane. A stone is attached to a string where there is limitation that string can't bear tension T. So T max is given as 9 Newton, and this will be equal to what? If it is moving with velocity v, radius is r, and mass is m, then I can write T must be equal to mr omega square or mv square by r, and everything is provided to us. String length is equal to how much? Mass is given as 0.5 kg, and v max we need to find, so that will be corresponding to T max. So v you can write under max under root T r divided by m, that comes out to be T 9 Newton. R is given as 2 meter divided by mass is 0.5 meter. So this implies 0.5, that means 20. It's like 4, and then taking root of that, it will come out to be 3 into 2, that is 6 meter per second. So we can see that just 1 second. Okay, a stone, let me just check the calculation here. It's mismatched a little bit. A stone of 0.5 kg is attached to a string of length 2 meter and wheeled in a horizontal circle. Okay, if the string can withstand a tension of 9 Newton, the maximum velocity with which the stone can be wheeled, so that should be like T, its tension is given as 9 Newton, then I can write T max, right? Because it's given, it's like rotated in horizontal circle, so that is the condition. Actually a tension will be providing the required centripetal force. Then you can write T is equal to m r omega square or mv square by r. Just rearranging it, T into R divided by M will be V square, and then root over that. So T is given as 9 Newton maximum, R is 2 meter, and am I taking everything in proper dimension? Okay, 9 Newton, and this is 2 meter divided by 0.5. So it will be like decimal 20, then it's 4, and root over this is 36. So okay, the answer will be like 6 meter per second for question number 4. Okay, next question number 5. A car is moving in a horizontal track of radius 10 meter. So question number 5, radius is 10 meter and it's given as with the speed of v is equal to 10 meter per second. A car is moving on a horizontal circular track. So this is the car. Then what will be the happening actually here? So the car will have a centripetal acceleration, and we can write the centrifugal acceleration will be like this, that is r v square by r. So if I look at it from like inside, then what will happen actually, if let's suppose this is the ceiling roof of the car, then if car is at rest, the bob must be suspended like this. Okay, a plumb bob is suspended from the roof of the car by a string of length 1 meter. So this length is 1 meter. Then if no acceleration is there, then what will happen? This will be the mg. So the string will be suspended, bob will be suspended in this position. But now what is happening, it will be like having centrifugal acceleration. So one force, that is m a centrifugal, that is equal to this AC, must be acting in this direction. Then what will happen, it will align itself in angle or at an angle along the net resultant force, is it? And let's calculate MAC. So we can write here tan theta is equal to MAC divided by mg, gets cancelled, this is AC divided by g. Now AC is equal to how much, v square by r. V is given as 10 meters square divided by r is 10, that is also equal to 10, and g is also equal to 10. So substituting, this is 10 divided by 10, we are getting it's 1, that means 10 theta equal to 1 means theta equal to 45 degree. This is answer to problem number 5, which is matching with option 3. Next question number 6. A body is moving in a vertical circle such that the velocity of body at different points are critical. Okay, the ratio of velocity of body at an angular displacement 60 degree and 120 degree from the lowest point. So first thing is, in this body is moving in a vertical circle, and we know actually here critical speed u and here critical speed v, and v is equal to under root gl if l is the length of this string, u critical is under root 5 gl. And by conservation of energy, I can get the velocity relation v at any angle theta. So that is related this way, v square is equal to or its relation is u square equal to v square plus 2gl 1 minus cos theta. Now here I can write u already given as critical, so v can be written as v square is equal to u square minus 2gl 1 minus cos theta, and u is equal to how much, root 5 gl. Substituting the values, okay, so for theta equal to 60 degree, I will get b1, let's say square is equal to u1 square, that is 5gl 1 minus 2gl 1 minus, this is cos 60, that is 1 by 2, it's half, basically that's coming out to be 4gl. So v1 is square, and this implies v1 is equal to this is 2gl. Okay, similarly for theta equal to 120 degree, then I will get v2 square is equal to again 5gl minus 2gl, this is 1 minus cos 120 is equal to sine minus of sine 30, that is plus half. So this comes out to be 2 overall 2gl, right? Then v2 square is this implies v2 is equal to under root 2gl, and this implies, now it's asking the ratio, okay, right, the ratio of velocity of body at an angular displacement 60 to 120 degree. So that means v1 by v2 it's asking, and that is equal to this 2gl divided by root 2 gf, that is equal to root 2 versus 1. This is answer to the problem, and that actually like not matching with none of the option, but it's given as answer is given as 4, but actual answer will be this. So just make it correct, actually that like not exactly matching with the option, because it's given as 2 ratio 1, but answer is actually root 2 ratio 1. Just take care of that. So next question number 7. And a body of mass m is rotated in at uniform speed along a vertical circle. Remember that it's clearly mentioned it's rotating at uniform speed in a vertical circle. So a body rotated at uniform speed in vertical circle, and here what will be happening, like on this body downward force mg, is it tension T1. So now centripetal force required must be towards center, so I can write here T1 minus mg equal to mv square by r. Let's say v is the speed of the particle. When it is going at highest point, then also its speed is remaining same, but in this situation here tension will be downward, and T and mg will be also acting downward. So at highest point, this is you can write at lowest point, and T2 plus mg must be providing mv square by r same at highest point. So just it is asking now T2 minus T1 relation. Just one second. A body is rotated, body of mass m is rotated at a uniform speed along vertical circle with the help of the string, light string. If T1 and T2 are the tension in the body, in the string when the body is crossing highest, so T1 is at highest, that means this is T1 and this is T2 actually. Then I will write this is T2 and this is T1. Okay, now it is asking, all right, tension when then respectively which of the following expression is correct. So now what I can do, I can substitute from this minus this, it will simply cancelled out, and T1 minus T2, so it will be this implies T2 minus T1 minus 2 mg equal to 0. This implies T1 minus T2 is equal to this 2 mg. So that matches with option number 3. Next question number 8. And a small bucket containing water is rotated in vertical circle of radius r by means of rope. So small bucket like this containing water, and it's rotated by string or rope in a vertical circle. So now here what is happening here, actually the water in the bucket will be like free to fall, is it water, but force acting on it is like mg because of its weight, and that must balance the centripetal force. Then there will be no net force on it, is it, because it required centripetal force also. So then simple, let's say the mass of water in a bucket is m, this radius it's given as r, capital R. Then what I can write, simply the mg, if it is balancing exactly, or I can write the required, it's now asked condition given is that if V, a small bucket containing water, is rotated in vertical circle of radius capital R by means of the rope. If V is the velocity of bucket at highest point, then water does not fall down if, is it? So if like water does not fall if mg, downward force, is less than equal to its required mv square by r. Simplifying it, we are getting V must be greater than equal to under root Rg. That is the answer to problem number 8, and that matches with option 3. Next question number 9. Two balls are thrown at the same time in air. While they are in air, the acceleration of their center of masses. So here you can write for ball 1, a1 is equal to g downward, and ball a2 is also equal to g downward. And then if we calculate it with the formula of center of mass, then center of mass will have same acceleration, that is a com will be also equal to g downward, right? So equal to acceleration due to gravity, option like 4th or D. Uniform wire is bent in the form of rectangle of side L and W, is it? So here uniform wire, this is a rectangle, one side is L and other side is W, all right? So actually it's given as, this is given as L and this is given as W. Then we know it's center of mass from, if I take this is origin, it will be where? Center of mass will be at center, and the coordinate of center of mass will be like L by 2 comma W by 2. So that option matches with again 4 or D, right? That is problem 10. Okay, so next problem number 11. A bob of mass m at rest and coordinate origin explodes. So here question number 11, there is this is origin and one bob is placed here actually, and which is exploding. Okay, explode into three equal pieces. Let's say mass m, then I will write total mass of this particle is 3m. So it's exploding into 3 particles of mass m each. If at a certain instant, one piece is at on the x-axis at x is equal to 40, so one piece is here m, this is x is equal to 40 centimeter. Another piece is at a certain instant, okay, another is at x is equal to 20 and y is equal to minus 60. So another is at here, x is equal to 20 and y is equal to minus 60, basically somewhere here. M, this is 20 comma minus 60. Then it's asking find the position of the third piece is. So in this situation, let's say the position of third piece is m is x comma y. Initially center of mass is where? at origin, and it's exploding means no external force is there, so means center of mass must not change. So that means I can write XCOM will be like m into 40 plus m into 20 plus m into x divided by total mass 3m. This must be equal to 0. Just simplifying for this implies x is equal to minus 60 centimeter. So the x coordinate should be minus 60. Similarly, for y coordinate, I can write YCOM is equal to m into 0 plus m into minus 60 plus m into y divided by 3m should be equal to 0, and again we are getting y is equal to 60 centimeter. So the coordinate of third particle is coming out to be minus 60 comma 60 centimeter. X minus 60 and y, and that matches with option number C or third. Next question number 12. A and B, each of mass 50 kg, were riding on a boat moving with the speed of 10 meter per second. So there is a boat moving with the speed of boat actually. So this boat is moving and two person A and B. Let's say this is A and this is B. This is moving with 10 meter per second. Masses of A each is like MA equal to MB is given as 50 kg. And if B jump off, okay, the boat with respect to B is jumping off with the jump off the boat with the speed of 10 meter per second with respect to in the direction of the boat movement. So B is jumping in this direction with 10 meter per second speed with respect to boat. Alright, boat in the find the speed of A after the jump. So here we need to actually apply conservation of linear momentum. So it will have, let's say, the velocity V, then net velocity of A with respect to ground, is it? Oh sorry, VB with respect to ground, that will be like I can write 10 plus V. Initial momentum and mass of the boat is also given as mass of boat boat is given as 100. So total mass will be 100 and 50 50 200. So I can write P initial must be equal to P final, and that implies 200 multiplied by 10 should be equal to 50. This is multiplied by V plus 10, and 150 multiplied by V. Just simplifying this is 0 0 0 cancelled out, and this is 200 is equal to 5V plus 15V plus 50, and this implies we can write it it's 20V is equal to how much? That is coming out to be 20V is 150, and this implies V is coming out to be 7.5 meter per second. This is answer to the problem number 12, that matches with option B or 2. Next question number 3. The center of mass of 3 particle is 1 2 3 is at 2 comma 2 comma this. The position of the fourth particle 4 kg to be placed in the system so that the new center of mass is at 0 comma 0. So question number, this is 13. So 1 comma 3 like means total 6 kg. Center of mass is at what? 2 comma 2 comma 2. And next is 4 kg. We are placing it x comma y comma z, so that next center of mass of this system should be at 0 comma 0 comma 0, right? So because this is identical, and then we can just solve for x. So XCOM is equal to what? This is 6 multiplied by 2 plus 4 multiplied by x divided by 10, and this should be equal to 0 because it's given as it should be 0. Then simplifying it, this implies x is coming out to be minus 3, and similarly solving for y and z, we will get exactly it's minus 3 comma minus 3 comma minus 3 will be the answer to the problem, that matches with option A. Okay, next question number 14. So a spherical hollow is made in the lead of sphere radius capital R, such that its surface touches like outside of the lead sphere and passes through the center. What is the shift in the center of the lead sphere due to the following? Is it? So here basically initially there is a sphere we have, and then what is happening out of this sphere? So let's say its total mass is m, then one sphere of this radius r by 2, we can see it from the diagram, r by 2 is removed out. So what is the mass? Small m will be like density is remaining same, so I can write volume of this is equal to how much, radius is becoming now 4 by 3 pi r by 2 q, so it will be v by 8, so then it will be capital M by 8. Then I can write here center of mass XII will be equal to total mass into coordinate 0 minus m by 8 into coordinate, its coordinate is r by 2 divided by m minus m by 8, right? And solving this, we are getting this is coming out to be 0, gets cancelled out, this is r by minus 16 multiplied by 8 by 7, and this comes out to be r by 14. It's just asking about the magnitude, so it will be r by 14. It will shift this side, that will be negative, magnitude will be this, that is matching with option B or 2. Next question number 15. A man of 80 kg is riding on a small cart of 40 kg which is rolling over, along a level floor at the speed of 2 meter per second. He is running on the cart so that its velocity relative to the cart is 3 meter per second in the opposite direction to the motion of the cart. What is the speed of the center of mass of the? So here like little bit issue is there in the language. It's saying the cart which is rolling along, so it's like this doesn't there's no point of rolling actually. It's you can just assume the cart is moving and its wheel will be like, but overall cart is moving with the speed of 2 meter per second, 2 meter per second, and mass of the cart is given as 40 kg, 40 kg, and one man on this cart, it's moving in this direction with a mass 80 kg and with a speed of 3 meter per second, but with respect to cart. So velocity of man with respect to ground will be equal to, this is 3 minus 2, that is 1 meter per second left. Then velocity of center of mass is equal to what? VCOM is equal to 80 multiplied by minus 1 plus this is 40 multiplied by 2 divided by 120, that comes out to be 0. So answer to problem number 15 is 0. Next question number 16. In which of the following case center of mass of the rod is certainly not at the center? So it's logical question actually here. The density increases from left to right up to the center and then decreases uniformly. So I'm like possibility. If density here, this is the rod, density increases up to center and then decreases. I'm like increases then decreases, so again center of mass will be here and here and that will be again at center, right? And in next case it's decreasing then increasing, so again it will be similar situation. And option, the density continuously increases from left to right, then definitely you can just imagine like this is the situation, mass will be like in this sense, so definitely it will not be at center, it will be somewhere right. And in next situation if something like this, then it will be towards left. So in option C and D, center of mass will not be lying at the center definitely. Okay, so answer is C. I'm like option C and D. Figure shows a square plate of uniform thickness of side root 2 meter. 1/4 of the plate is removed as indicated. The distance of center of mass of the remaining portion from the center of the original square plate is. Okay, so in question number 17, it's asking 1/4 of the plate removed as indicated. The distance of center of mass of the remaining portion from the center of the original. So center of the original, let's take its origin, that is 0, 0. I can write its diagonal will be equal to how much? It's 2 meter. So definitely center of this will be like how much? At 1 meter distance. Then I can write here directly with the formula. RCOM will be equal to A multiplied by 0 plus because originally I'm taking the center of mass at origin, then minus its removed portion 1/4, center of mass is at distance 1, divided by again A minus A by 4, and center of mass will be at distance 1/2. This diagonal, this will be 1 meter, so this distance will be like, this distance will be 1/2, so it will be 1/2, and then simplifying it I'm getting 1/6 meter. So the answer to this problem will be 1/6 meter. I think it's given as 1/3 meter, that is not correct, it will be 1/6. Next question number 18. Two particle P and Q, P greater than Q, so this is P and Q, let's say the distance between them is D, then I can write center of mass will be somewhere, so it's R1, and let's say this is R2. R1 can be written as D, this is a QD divided by P plus Q. And now it's saying if position of these two particles will be changed, then what will happen? R1 will become R2, so center of mass will shift here, where this distance will be R1. Right, then this is the shift actually in the position that can be written as R2 minus R1, and R2 will be equal to what? This is PD divided by P plus Q. Shift is R2 minus R1, simplifying it's P minus Q divided by P plus Q multiplied by D. This is the answer to problem number 18. Next question number 19. So body of a boy of mass 50 kg is standing on one end of the boat of length 9 meter and mass 400 kg. So let's say this is a boat, one boy of mass, this is 50 kg, this is 400 kg standing, and this length is given as 9 meter. This is the problem. If he run to the other end, the distance through which the boat moves. So in this is a standard type of problem. Here you can write X boat, its formula is mass of the person who moved, object, you can write move, multiplied by distance. This is with respect to like this platform, is it, divided by total mass. This is the standard. We can get it directly from the by keeping the center of mass fixed, is it? So this mass of the person 50 kg, how much it's moving with respect to boat, because it's moving to other end, that is 9 divided by total mass is 4500. Mass of boat plus person, so 9, it's 5, and that comes out to be 1 meter. This is the answer to problem number 19. Next question number 20. One sphere collide with another sphere of same mass at rest inelastically. So this is one moving with, let's say, speed v. Another sphere m mass, same mass, but initial velocity 0, colliding inelastically. Coefficient of restitution, so this is, let's say, 1, this is 2. After collision, let's say the velocity is becoming v1 and velocity of this is becoming v2. Then 1 is by conservation of, so I can write mv is equal to m v1 plus m v2. This implies v1 plus v2 is equal to v, right, equation. Another is velocity of approach initially, so I can write 1 by coefficient of restitution, this is v2 minus v1 divided by, that will be velocity of approach is v, right. So this implies v2 minus v1 is equal to how much? V by 2. And then just simply adding these two and simplifying, we are getting actually adding these two, so v1 gets getting cancelled out, then v2 is coming out to be 3v by 2, and just subtracting it from here to there, I'll write 3v by 4, and then subtracting, then this I am getting v1 is equal to v by 4. So the ratio of ratio of v1 by v2, that comes out to be 1 by 3. That is answer to the problem, matches with option C. Next question number 21. The coefficient of restitution depends upon the mass of the colliding, definitely doesn't depend. Direction of motion of the colliding body, that also not. Inclination between the colliding bodies, no. The material of the colliding body, yes. Then material means like even these two bodies are hitting, then how much they will deform, that will depend on material. So definitely coefficient of restitution will depend on material of the colliding bodies. The angular velocity of the rotating body is omega, given linear velocity of the body whose position vector is, so here omega bar is given as 4 I cap, this is j cap, and minus 2 k cap. Position vector of a point or object is 2 I cap plus 3 j cap and plus minus 3 k cap. So it's linear velocity, then we know the relation v bar is equal to omega bar cross r bar. Simply taking the cross product of omega cross r, we will get v bar comes out to be actually 3 I cap plus 8 j cap plus 10 k cap. That's simple cross product, you can check it. Next question number 22. Table fan rotating at the speed of 2400 rpm is switched off, and the resulting variation of the rpm at the time is shown in the figure. The total number of the revolution of the fan before it comes to rest. So that angular displacement will be equal to actually area under this graph. Just calculate that and divide by 2 pi, then you will get total number of revolution. That just simply area under graph, and calculating we will get actually, so number of revolution, it will comes out to be around 280. Answer to the problem. Next question number 23. An automobile engine develop 100 kilojoule when rotating at the speed of 1800 rpm. So we need to convert that actually in like radian per second, and then we know actually power is equal to tau into omega. So power is given as 100 kilojoule, means 10 to the power 3 tau, and omega will be 1800 multiplied by 2 pi divided by 60. Simplifying it, tau we get around 531 Newton per meter. Right, this is answer to the problem number 24. I missed something. 20. All right. So this is actually 22, 21. I just solve that orally because it will be like material depending. Then next it's 23, and this is problem number 24. Let me erase the board. Okay, next question number 25. Average torque on a projectile of mass m, initial speed u, and angle of projection theta between the initial and final position p and q about the point of projection. So it's talking about the average torque. Average torque we can write is equal to what? So tau average is equal to delta L, change in angular momentum, divided by time, or delta t. So from point of projection, speed u, angle angle theta, finally it will be landing here, again this will be angle theta, and the speed must be definitely u. Then I can write, and this distance is equal to how much? R. So I can extend it back, then I will be getting, this is the perpendicular distance, R perpendicular, that is equal to R cos theta. R is the range, so R is how much? That is u square sine 2 theta cos theta divided by g. Time period is 2u sine theta divided by g. So initial angular momentum I can write it 0, mvr perpendicular. L final is equal to what? This is the R cos theta multiplied by u, that is L final. Time taken is this, so tau average can be written as L final minus L initial divided by t, that comes out to be this, R u cos theta minus 0 divided by 2u sine theta by g. Substituting all these values and simplifying, we are getting its m u square into cos square theta. That is the answer to problem number 25. Next question number 26. Okay, 3-point sized body, each of mass m, are fixed at the corner of the light triangular frame of side length capital L about an axis perpendicular to the plane of the frame and passing through the center of the mass frame, and moment of inertia of 3 bodies is. So here this is a body side triangular frame of side length L, and point masses are placed at its corner. So definitely this distance will be how much from centroid? This will be L by root 3. Then I total will be written as 3 times moment of inertia of one body, that is equal to 3 into one body is m into L by root 3 whole square. That comes out to be 3ml square by 3. It's coming out to be ml square. That is answer to problem number 26, that is option 1. Next question number 27. So I is the moment of inertia of the thin square plate about an axis passing through opposite corner of the plate. The moment of inertia of the same plate about an axis perpendicular to the plane of the plate and passing through its center. So here it's saying diagonal, this is I, then definitely by symmetry I can write this will be also I. Then moment of inertia about this axis will be written as by perpendicular axis theorem, Iz is equal to Ix plus Iy. So this is I plus I, that will be equal to 2i. Answer to problem number 27. Next 28. A ballet dancer is rotating at angular speed omega, and the ballet dancer fold his hand fold his body close to his axis of rotation, by which the radius of gyration decreases by 1/4. So if radius of gyration is initially k, then I can write initial moment of inertia as m k square. Now radius of gyration decreases by 1/4 means you can write k prime is actually equal to 3k by 4. So that means your I prime will be equal to how much? 9k mk square by 16. Then by conservation of angular momentum, I can write mk square into omega should be equal to 9k square m by 16 into omega prime. This implies changed omega is 16 omega by 9. That is answer to problem number 28, matches with option 4. Next question number 29. A thin uniform circular disc of mass m and radius capital R rotating in a horizontal plane about an axis passing through its center and perpendicular to the plane with an angular velocity of omega. The another disc of same mass but half the radius is gently placed. So we have one disc rotating angular speed omega, mass m, radius. So I initial can be written as mr square by 2 and L initial is mr square by 2 into omega. Now another disc of same mass but radius half of it. So its radius r by 2. Then total I can be written as mr square by 4 plus mr square, that is equal to 5 mr square by 4. So because inertia, like moment of inertia has changed, so angular momentum must remain conserved, so angular speed must change. So that means L final should be equal to what? 5 mr square by 4 multiplied by omega prime. This must be equal to that, and this implies omega prime is equal to 5 omega by 4. That is answer to this problem, matches with option number 2. Next question number 30. A thin rod of mass m and length L is bent in the form of, so this is a rod of mass m and length L. This is bent in the form of ring. Then its radius will be equal to what? I can write 2 pi r is equal to L. That means r is equal to L by 2 pi. Moment of inertia of this ring ring is equal to m r square. Substituting this value here, so I is coming out to be m L square by, this is what it's asking. Okay, the moment expression for moment of inertia of the ring about an axis passing through its diameter. Then about its diameter, actually it's mr square by 2. Substituting it will be like 8 pi square. This is answer to problem number 30, which is matching with option 3. Okay, next question number 31. A circular ring of mass capital M rotating about its own axis in horizontal plane at an angular speed of omega. So this is initially rotating at an angular speed of omega. So you can write L initial is equal to m r square into omega. Now what is saying, like if 2 point size bodies of each mass small m are gently attached to the rim, so means 2, like this is small m and this is also small m. Point bodies are gently attached to the two ends of its diameter, then angular velocity, so definitely what? Angular momentum will remain conserved, so omega will change. So L final will be equal to how much? This is mr square, because rings moment of inertia is remaining same, mr square plus due to this mr square plus due to this also mr square, that comes out to be capital M plus 2 times small m into r square. What is L final? This is I final. So L final will be equal to I final into omega prime. This must be equal to initials. Simplifying it, we are getting omega prime is equal to capital M into omega divided by capital M plus 2 times of small m. That is answer to problem number 13, matching with option number 1. Question number 32. That is 31. A ballet dancer is rotating about its own axis, vertical axis, on a smooth horizontal floor. The moment of inertia of the dancer decreases by 20%. So let's say initial moment of inertia is I, angular speed omega. Now I prime becoming decreases by 20% means it is becoming 0.8 I, and when he fold himself close to his axis of rotation, the percentage change in its rotational kinetic energy is, okay, so rotational kinetic energy K initial you can write half I omega square. First thing is let's calculate the omega prime. So by conservation, L initial is equal to L final. This you can write I into omega is equal to 0.8 I into omega prime. So omega prime is equal to how much? This is 5 omega by 4. Then initial kinetic energy. Alright, just wait one second. The percentage change in its rotational kinetic energy K increases. So here we can see the momentum, angular momentum has increased. So final kinetic energy will be equal to how much? 1 by 2. This is 0.8. Moment of inertia has decreased, and omega, this is 25 omega square by 16. Right? So just simplifying it, we are getting it. This is coming out to be divided by 10, then decimal. This is 4, 2, and then it's like 5, 2 also gets cancelled. So K final is coming out to be 5 by 4 into half I omega square. So you can check it actually, the percentage change delta K divided by K initial into 100. Simplifying it, it comes out to be 25% increment. So kinetic energy increases by 25%. Next, question number 33. The frequency of particle performing SHM is given as f is equal to 12 Hz, and its amplitude is given as 4 centimeter. Its initial displacement x initial t equal to 0 is given as 2 centimeter. So means it is lying at, this is our mean position, extreme position, this is at a by 2. So that means initial phi initial will be equal to what? Pi by 6, corresponding to a by 2. Okay, it's equation of displacement. So x is given by a sine of omega t plus phi, and then it can be written as a is 4 sine, omega is 2 pi f. So 2 pi f means 24 pi multiplied by t plus phi is pi by 6. This is answer to the problem, which matches with option number 3. Next, question number 34. The resultant amplitude due to the superposition of the SHM x1 and x2 is, so this is 10 sine of omega t plus 30 degree minus 10 cos of omega t minus 60 degree. Just we need to rearrange it actually. So this is remaining same, I am doing it with this, plus it can be written as 10 sine of omega t minus 60 plus 90, because just one second, no, this can be written as like this. Let me write it simple. I'm just changing this, so it will be minus, then you can see sine of something like, let's say this is total theta, sine of 90 plus theta will be equal to how much? Cos theta, right? And then this minus is remaining as it is. So then what is that? It's coming out to be minus 60 plus 90, that is equal to 30. So this is 10 sine of omega t plus 30, and this is minus 10 of sine of omega t. This will be equal to plus 30. So then here it's exactly negative, it's positive, so they will cancel out. So resultant amplitude will be, position will be 0. So that is answer to problem number 34, matches with option 4. Next, question number 35. Amplitude of oscillation of a particle that execute SHM is given as 2. So 35, amplitude is given as 2 centimeter of a SHM. Alright, its displacement from its mean position in a time equal to, so I can write it, let's consider the particle is starting initially from origin, then I can write origin mean equilibrium position basically. So its position will be like a sine of omega t, and it's saying displacement in displacement from its mean position in time equal to 1/6 of its time period. So 1/6 means t is equal to t by 6, that is 2 pi by 6 omega. So then I can write, let's calculate its position, that will be its displacement. This is a sine of omega multiplied by t, 2 pi by 6 omega. This omega cancelled out, this is pi by 3. So sine of pi by 3 is how much? Root 3 by 2, and a is given as 2, so x is equal to 2 multiplied by root 3 by 2, that comes out to be root 3 centimeter. This is the position of particle at t by 6 time, and because initially I am taking according to this equation, that means initially particle is at mean position, so this position will be equal to displacement, so that displacement will be root 3 centimeter. That is answer to problem number 35. Next question number 36. So here it's saying a body executing SHM has maximum velocity, so Vmax is equal to 1 meter per second, and we know that is equal to A into omega, amplitude multiplied by omega, and maximum acceleration of 4 meter per second. So maximum acceleration 4 meter per second, that means A max is A into omega square, that is given as 4. Just dividing this by that, that means omega is coming out to be 4 radian per second, and substituting here, so amplitude is coming out to be 1 by 4, that is 0.25 meter. That is answer to, because it's asking about amplitude, question number 36, that's correct. So amplitude is 0.25 meter, actually yes, it will be meter. Message with option number 4. Question number 37. The equation for the displacement of particle executing SHM is given. Then velocity at 3 centimeter from mean position. So question number 37, x is given as 5 sine of 2 pi into t centimeter. That means a is equal to how much? 5 centimeter. Omega is given as how much? 2 pi. Then we know the relation v is equal to omega under root a square minus x square. Clear? Just substituting v is equal to omega 2 pi a 5 square minus, it's given as asking at 3 centimeters, so that means 3 square. This implies v is coming out to be 8 pi centimeter per second. Simplifying it, so that is your option 4. Let me just erase for next. Okay, next question number 38, and it's given the for a body in SHM, the velocity is given by, so v is given as under root 144 minus 16 x square. The maximum acceleration is, so first let me rearrange it. Omega, I can take 16 out from it, so it's 4, then it's under root 9 minus x square, and this can be written as actually 4 under root 3 square minus x square. Comparing it with the standard omega under root a square minus x square, that means omega is 4, a is given as 3, and acceleration is a omega square, that means 3 multiplied by how much? This is 16, 4 square. So 16 into 3, that comes out to be 48 meter per second square will be the maximum acceleration of particle performing SHM. Question number 39. Figure shows the displacement. So this is a figure. So it's a maximum velocity 0.6 meter per second. Maximum displacement is 10 centimeter. Right, find time period, so means we need to get omega. So we know v is equal to what? A into omega. V is 0.6 meter per second, a is 0.1 into omega, and this implies omega is equal to 6 radian per second. Then time period is 2 pi by omega, that is 2 pi by 6, that comes out to be pi by 3 second. That will be the time period. Matches with option 1, question number 39. Next, question number 40. At what displacement the kinetic energy of the particle performing SHM is of amplitude? So amplitude is given as 10 centimeter and 3 times its potential energy. So kinetic energy must be equal to 3 times of potential energy. Kinetic energy can be written as half mv square, that can be written as 1 by 2 k. This is a omega square a square minus x square. Potential energy is equal to half k x square, right? This can be rearranged, k a square minus x square, right? And then it's just using this relation, so this implies half k a square minus x square is equal to 1 3 by 2 times k x square, k 2 3 cancel, a square minus x square is equal to 3x square. This implies x is equal to a by 2, right? So that means a is given as 10 centimeter, it's 5 centimeter. That is the answer to the problem. Next, 41. So a particle is oscillating simple harmonically from its equilibrium position, then ratio of kinetic and potential energy of the particle at t by 12. So let me get what is the position of particle at t by 12, and it's given from its equilibrium position. So t is equal to 0, particle is at x is equal to 0, and then I can write x is equal to how much? A sine of omega t, and t by 12 means 2 pi by 12 into omega, that is pi by 6 omega t. Substituting x, I am getting this is a sine of omega multiplied by pi by 6 omega, that comes out to be a by pi, sine pi by 6 means 30, that is a by 2. So at t by 4 the particle is at a by 2, then kinetic energy and potential energy can be written. So this is x, so then potential energy half kx square a square by 4 ka square by 8. Kinetic energy half k a square minus a square means x square, that is equal to 3 ka square by 8. So now it's asking about the ratio of kinetic energy. All right, just one second. So this is the okay, so kinetic energy to potential energy, that comes out to be 3 by 1. That is answer to problem number 41, matches with the option 2. Question number 42. Two masses capital M and small m are suspended together by a massless spring of force constant K. Okay, when all right, this is the situation. So two masses are suspended. This is small m and capital M. So total expansion in the spring will be like x will be equal to you can write k x1 is equal to capital M plus small m into g. Now what it's saying, when the masses are in equilibrium, capital M is removed without disturbing the system, then the amplitude of oscillation. So then once m is removed, now equilibrium position will be at x2 will be small m, like you can write kx2 is equal to small m into g. This force will be balanced, this is the equilibrium, but extension is equal to how much? x1. So amplitude is given by x1 minus x2, and that comes out to be capital M g divided by capital K. This is the amplitude, which is matching with option number 1. Okay, next. Okay, next question number 43. It's saying spring block system, length of the spring is reduced by 1%, time period. So first, how length is related to time period, we need to get that. So k is inversely proportional to length, omega is under root k by m, time period is 2 pi by omega. Substituting the values, it's 2 pi, because mass is remaining constant, so that means I can write omega by m by k, and substituting this relation I can write t is directly proportional to what, it's root l, because k inversely, so substituting it, this is the relation. Then I can taking it l and differentiating delta t by t is coming out to be 1 by 2 into delta l by l. So this multiplied by 100 multiplied by 100, this is the percentage change in length, then percentage change in time period is given by 1 by 2 into that is 1%, that is equal to 0.5%. that is the answer to problem number 43. Next, 44. acceleration due to gravity on the planet is 3 by 2 times that on the earth. So here time period is given by 2 pi under root L by G. Is it? If length of the second pendulum on earth is 1 meter, so I will say L is given as 1 meter. Then on another planet G prime is becoming 3G by 2, then L prime will be equal to, because time period will remain same, so I can write T is equal to 2 pi under root L prime divided by 3G by 2. Just dividing it or equating these two, so we are getting this cancelled out. This is L prime by 3G by 2 should be equal to L by G. G gets cancelled. L prime is 3 by 2 L, that is L is given as 1 meter, so it's 1.5 meter. Question number 44. Next, question number 45. The amplitude of damped oscillator become 1 by 3 in 2 seconds. So amplitude is related, A is equal to A naught e raised to power minus bt by 2m. Right? It's given as its amplitude is becoming 1 by 3 in 2 seconds. So means A naught by 3, A naught e raised to power minus b into 2 by 2m. Next, it's saying its amplitude after 6 seconds will be 1 by n times. So after 6 seconds, that will be like a naught e raised to minus b into 6 divided by 2m. Okay, and this can be written as basically a naught e raised to minus b by 2m multiplied by, or I can just take it into 2 multiplied by 3. This is same equivalent, and now from here a naught gets cancelled. This implies e raised to minus b into 2 by 2m is equal to how much? 1 by 3. Substituting it here, this implies a is equal to a naught, this value is equal to 1 by 3 power 3, so a is becoming 1 by 3 power 3, a naught by 3, and that is like 1 by n times, so n is coming out to be 3 power 3. This is answer to problem number 45. I hope you understood all the problems. I hope all your doubt must be clear, and this is all about solution of DT08. Thank you so much.